Hello everyone and welcome to the solutions video for Codeforces Round 770. This was a pretty good round, I think, even though I was not able to solve B. I know the solution now after discussing with my friends, and I'll be explaining A to D. I was able to solve ACD. I was hoping I would get a positive 100, but if not that, I can always get negative 100, right? So yeah, let's begin. I was hoping this would open and show the negative 100 when I said it. Not the best comedic timing, but whatever. Let's begin. Problem A. In this problem, we have a string, let's say like ABC, and what we can do in one operation is take its reverse, so that is CBA, and concatenate them in any order. So either ABC plus CBA. So this just becomes like ABC CBA, or we add it like CBA ABC, and we can do it k times. We have to do it k times actually, and what we have to, right? Yeah, exactly k times. And what we have to tell is what is the total number of different strings we can get after k operations. So first of all, let's see what kind of symmetry there is in this operation. So since we are concatenating the reverse, let's see if there's any symmetry with the palindrome. And if this was a palindrome, then its reverse would be same. So adding it in any order, either I add the first before second or second before first, I always get the same string, and by property it will also be a palindrome. So this means I only get one string. If my initial string was a palindrome, after one operation I get only one string, and that is also a palindrome. So by induction or basic deduction, we can know that after k operations as well, we will have only one string. But what if it is not a palindrome? What happens then? So let's take our original example ABC and the reverse is CBA. Now, no matter which way you add it, right? So either this or this, you will end up with a palindrome because it is the reverse. Both of them are reverse of each other. And that is why this would be equals to this would be equals to this would be equals to this. And hence, I will end up with a palindrome. And since I end up with a palindrome, now if I do it again, I will end up with only one string. So if the initial thing was not a palindrome, then I branched out into two things, right? So one is ABC CBA and one is CBA ABC. Now these two are different, but now this is also a palindrome and this is also a palindrome, and they will always remain a palindrome. So there will be two options. And obviously if k is 0, answer is 1. So let's look at the implementation. It is extremely simple. What we do is input, check for palindrome. If it is a palindrome and there is some number of operations, sorry, if it is a palindrome or k is 0, then answer is 1. Otherwise it is not a palindrome and k is greater than 0, so print 2. Now problem B. In this problem, okay, let me remove this. This problem, we have an array just like usual, and we have two starting numbers, x and x plus 3. And what we can do is for every I from 1 to n, we process x in this way. So x can either become x plus ai, or x can become x XOR ai. And then at the next step, it would branch out into two possible things. This will branch out into 2, and so on. So this keeps on happening. And then in the end, we end up with a bunch of possible values. And we are also given a value y. And we have to tell if x or x plus 3, which of them will be able to reach y. And it is given by constraints that only one of them will reach. So input is such that only one of them will be able to reach. So we have to tell which one would it be. Now, this is plus and this is OR. And if you try to simulate this, you will realize that actually we get 2 to the power n different values, because the range of AI is also pretty big, so we cannot actually simulate it. So how do we approach this problem? We have no idea how to simulate it or anything. So how can we do it? Notice that we don't actually have to figure out if one can reach, because we what we have to see, what is this? Okay, so this is a relative question, so we have to see that if x can reach, then x plus 3 should not be able to reach. Okay, I have made it a little bit too big. Yeah. Oh, what is this? I think this. No. Sorry, I'm wasting time over here. Yeah, this is good. Okay, so we have to kind of observe in a relative way that will x reach or x plus 3 reach. Okay, we cannot absolutely determine it because of the constraints of the question. So what is the difference between these two? The difference between these two is the difference in their parity, because one, if x is even, x plus 3 will be odd. If x is odd, x plus 3 will be even. So parity matters, and this is the clue to the solution. If you do not realize this, you won't be able to figure it out. Okay, so now let's see what happens on an operation on the parity, because parity matters. Let's see how parity changes with an operation. So if you have an odd number would be something like this, where last bit is 1. Okay, if you take its XOR with an even number where the last bit would be 0, its parity would remain same, and even if you were to add it, that even number, the parity would remain same. Now what if you XOR with an odd number where the last bit is set? Then you will reach a different parity, and even if you were to do an addition, you will reach a different parity. So that means that on an operation with an odd number, the parity changes or parity reverses, while operation with an even number does not change the parity. And so now let's look at this whole operation. So let's say the array was like this. Okay, 5 3 2 2 6 1, and we have initial 10 and 13, and let's say we want to reach 15. Okay, so this would change the parity, this would change the parity, these won't do anything, this would change the parity. So parity changes once, twice, once, so in the end parity would change. So that means that 10 would become an odd number and 13 would become an even number, and 15 is an odd number. So just by the final resultant parity, we can figure out which one would be able to reach. And because it is given that one of them reaches and exactly one of them reaches, so we can be sure that only this will reach. So that was the solution. I don't really have code, but I think it's pretty simple. You just iterate on the array, count the number of odd numbers, and then modulo it by 2. So if the number of odd numbers is odd, then the parity changes, otherwise parity remains same because they cancel each other out. And if parity has to change, then we are gonna pick where of them has different parity from y, and if parity does not change, we are gonna pick whichever of them has same parity as y. So that was a brilliant question, I think, mostly because I was not able to get even close to the solution. It's mostly because I did not think that we just have to analyze on parity, but that's me being stupid. Now let's look at problem C. Let's delete this. I actually like this whiteboard the most. It's pretty nice. It looks good. The colors are nice and the features are also nice. If only it had dark mode. So OKEA. Okay, so in this we have to construct a matrix. Okay, so a matrix of dimensions, what are the dimensions, wait a second, n by k, and we have to put numbers from 1 to n times k in each of these cells. Every number must come there, so it can be like 1, 3, 2, 4, 5, 6, 7, 8, and so on. And what we want is, what the constraint is that for every row, every subarray has to have an integer mean. So let's take this subarray. So this was the 8, right? So this subarray 285, its mean should be an integer. So 8 plus 5 plus 2 divided by 3 should, and what does this give? This gives 5. So this is good. And however, let's take this one. Let me remove this. Let's take this one. So its sum is 8 plus 2 plus 1 divided by 3. That is 11 by 3. This is not an integer, right? So this does not belong to the integer set. So this violates the constraint, and this becomes an invalid matrix. So basically we want every subarray in every row to be divisible by its length. That's the same thing said differently. So let's see how we can get it. Now obviously we cannot put consecutive numbers adjacent to each other, right? Because if they are adjacent, their sum would be odd, because even plus odd is odd, and that won't be divisible by 2. So we cannot put consecutive numbers. So let's try to put the alternate numbers. So 1, 3, 5, 7, 9, and these alternate numbers have a pretty nice property. So this is an AP where where the first term is this, difference is this. If you were to find the sum of first n terms, what would be a plus n by 2, 2a plus n minus 1 times 2. And if you were to calculate this, okay, so what I was going at, okay, I don't know if I can actually derive it right now, but their sum is actually, so the sum of first n terms here is equals to n square. So sum of first term is 1 square, first 2 is 4, 2 square, first 3 is 9, 3 square, first 4 is 16, 4 square. So you can derive it from that arithmetic progression. Yeah, AP sum, maybe, I'm not sure, but it should be possible. Now, so this is the property of it, and there's actually a geometric proof too. Basically, if you were to assign values like this or something like that, I'm not sure. Okay, I got sidetracked there. Now let's see the actual question. So because this sum is n square, that means if you take the subarray starting from 1 up to, let's say, k length, then their sum would be k square, and it is divisible by k. So it actually satisfies our given property for everything. Okay, and if we were to displace it by some value, so let's say we displace it by 1, so what we get here is we add 9 and we remove 1, which is also then is also a multiple of k. Okay, so this difference is also a multiple of k, so the sliding window over it always remains divisible by that length k. So with this we are sure that let me just remove everything. So with this we are sure that if I write it like this, then this is a proper row. And then for the next row I can maybe write like this. Because the sliding window also satisfies that property, I can write it like this and it works. But what about the even ones? Well, let's see. Let's try to write it in a similar way. This 2, 6, 4, 8, 10, will this satisfy the same property? Well, notice that the first n terms of this, or first k terms, is actually equals to k square plus k. Why? Because it is the same series as this, with every term has one extra value. Every term is one more than the term in that sequence. So 1 added k times becomes k square plus k. So it is also divisible by k. So this also satisfies it, and the sliding window in this also satisfies it. So this is our construction. What we can do is we can assign for every row values like 1, 3, 5, 7, 9, and then assign 11, 13, 15, 17, 19, and then once we are done with all the odd numbers, then we can do the same for all the even numbers. And obviously odd number and even number do not come in the same row, because if they do, like 11 and 12, they will not be divisible by 2. So that is why we have to keep odd numbers in separate rows and even numbers in separate rows, and their sequence should be alternating values. And now notice here that if this was the dimension, right? If this was the dimension, this would actually not work out, because and this k, what is k? 1, 2, 3, 4, 5. 5 times 3, 15. We actually have to use values up to only 15. This column, this row is actually using some extra values, which is 17 and 19. We have to use 12 and 14 here, but if we do, we will violate the property. So this is also not possible. So we just have to construct it like that and then check that we are not exceeding n times k at any cell. And that is exactly what I have done. So I take in the input, and obviously n equals to 1 is a special thing, I guess. Okay, no, this is not necessary. This is the answer. So I'm generating the answer. For some reason, I decided to have it like this. So it is 1, 3, 5, 2, 4, 6, 7, 5, 7, yeah, 9, 11, something like this. So I added alternation here as well for no reason. So that is the thing, and then I'm checking that if I ever exceeded n times k, print no. Then I add for even, and if I ever exceeded n times k, print no, and then finally print yes and print the vector. If you don't know how this printing is working, obviously you can check out my template tutorial where I explain this IO overloading, and also please subscribe. I want subs. Okay, now final problem D. Did I FST? No, I did not. Good. So in this problem, we are given an array. We are not actually given an array, but there exists an array where one element only is 0 and all others are non-zero. And we can do some sort of query. This is an interactive problem, by the way. What interactive problem means in a nutshell is that input is given only when we output something. So we basically ask it that, okay, give us input for this value, and the what is it called, the online judge, the judge returns us that specified value, and then we process that, and then we ask more things, and then finally we print answer. So input is not predetermined. It gives us input based on what we ask for. And what we can ask for is, we can take three indices, ai, aj, and ak, and it would give us the value of maximum among these. So maximum ai, aj, k minus minimum ai, aj, and ak. So, and what we have to do is find out where this 0 exists. And the maximum number of queries we can do is 2 times n minus 2. So it is like this, not this. I wasted 40 minutes because I thought it was like this. So just a heads up, it is like this. Okay, so now we know what query we can do. Let's see how we can do it. So for now, assume 0 is somewhere here. And let's say a1 and a2 are some random values, and so here two values matter to us. Okay, one is 0, obviously, because that's what we want to find, and another is the maximum value in a. And why is that so? Is because let's say I have a max. Okay, then what I can do is I can take some random value ak, and using these I fix these two and then query with every ai. So basically, let's say a max was at a5, I choose any random ak3, then I will query these two with a1, a2, a4, a6, and so on. So I query it like this, and when we do this, what will happen is this. So ak is somewhere about here, right, and a max is here, and then 0 is somewhere here. So all these values exist in this range. So when I will do the operation on them, the result would be less than a max, and it would be exactly a max at 0, and that would be the maximum value. So if I have a max, I would be able to find where 0 is by doing this operation over everything, and whichever has the maximum value, whichever index gave us the maximum value, will have 0 in it. And if uh, I had 0 and I do the same thing, then I will be able to figure out where a max is. The situation where I choose 0 and a max as the default ones, and then I iterate over every I, that is a little bit confusing, and there we cannot actually properly decide where a max is. So that is the thing. So if I choose exactly one, either 0 or a max, then I can figure out where the other one lies. Okay, so that is why 0 and a max are important. If you try different type of operations with it, you will realize this. That's how you realize this. Okay, so now let me just remove this. So now let's pick two random values. So for now, let's say I fix these two values, and then I iterate over all a3 to an, right? And obviously, if a1 and a2, one of them is a0 and one of them is a max, then everything would be a max, and I won't be able to tell like what is the other values. Or I basically, it's very ambiguous, because one case is obviously they have, one of them is 0 and one of them is a max, but there's another case, something like this, 2 1 0 3 3 3. So that is basically the values I have picked. So one of them is like a max by 2, and the other is something like a max by this. So something like this causes issue. Okay, I don't want to explain this because then I would go on a tangent, but take my word for it and try to obviously prove this, or at least see why this works. But if one of them is 0 and one of them is a max, you don't actually get a lot of information out of that. So what we are hoping is that the things that we have randomly selected, a1 and a2, one of them is at least, so one of them can be 0, one of them can be a max, but both of them are not 0 and max. Okay, so that is what we are hoping. Now we will make sure this happens later, but first of all, let's see how we can use this much, that if the first two we have selected are not both containing 0 and max, then how we can figure out two possible candidates for the position of 0, because we have to output two probable positions where 0 is. So if I were to take these two and then iterate over them and do the query, I will, so a1 is somewhere here, a2 is somewhere here, 0 is somewhere here, and a max is somewhere here. So notice that the maximum value I will get will either be a2 minus a max or a2 minus 0. Sorry, a max minus a2 or a2 minus 0. Either way, it would be either belonging to position of 0 or position of maximum. So with that, I'm able to establish where a max or 0 exists. So now that I have that position, what I can do is choose one of them to be this. So now among the fixed two values, one of them is this and other is either of these two. So let's take a1, and then I do the same, iterate over every value a2, a3 except these, right? And now so it doesn't matter if I have a max or 0 here. In both situations, the resulting values that I will get would again have a peak somewhere, and that would represent the other thing. So if I had 0 here, so if 0 was here, then I would get the maximum value at a max, and if I had a max here, I would get the maximum value at 0. And why is that so? So right now I'm assuming sorry, not a2, right now I'm assuming a1 is not 0 or max, right? So okay, it can be max, it doesn't matter, but it is not 0. Okay, so basically it's not equal to this value, equal to the complement of this. So basically 0's complement is the maximum and maximum's complement is 0, just for sake of expression, I guess. So if one of them was a maximum, other was some random value, okay, then I iterate through all the values, I will get the maximum answer when other is 0, because then minimum is the least. And similarly, if one of them was 0, other was some random which is not maximum, then once I iterate through everything, I would get the maximum where the maximum value is encountered, because this is the maximum. Maximum minus 0 would be maximum. So this way I will be able to get the other pair, and now I have one probable position, and then with the second loop I was able to find the second probable position, and I can output those two. However, what if this was 0, right, and this was maximum? So basically, if it was like the candidate that I had chosen, so this is candidate, was maximum and a1 was 0, so in this case everything would also be max, because these two will dominate every other criteria. They have the maximum and the minimum. Similarly, if it was like 0 and max, again I would get maximum everywhere, and if I get maximum everywhere, then I know that these two are the actual candidates. So with this, given that the first two numbers that I have chosen are not 0 and maximum, I can figure out where 0 and maximum are occurring, and I can output those two, and if I output those two, I will get a correct answer. But what if the values that I choose are 0 and maximum? In that case, let me explain why it does not work. So let's take two examples, 2 1 0 4, which is the same thing as the sample, and let's take another 2 1 no 4 0 and what is it, 3 3, it doesn't matter, 3 2, doesn't matter. Now if I'm selecting the first two and then querying with 0 and 4, what will I get? Here I am getting 2 minus 0 2, and there I'm getting 4 minus 2 2. So these are same, but they are not maximum. And here I am getting, so these two are overwhelming everything, so I'm getting 4 everywhere, but this is the max. However, I do not know this, because initially I don't know that one of them is a max or not. If I knew one of them is, then I'm sure how I will figure, then I'm sure that if all of them are equal, then other is my complement. That's what we did in the previous slide, I guess. But initially we are not sure. So how do we avoid this? Now there are multiple ways to do this. I think how I did is so 1 to n, right? Let me go to my code. So notice that this iteration operation, this requires n minus 2 queries. I'm doing it 2 times, so this is 2n minus 2. I have 2 more queries left, so that's what I noticed and took advantage of. Okay, please open. It is getting awkward. It's getting very awkward. CP. I think this works too. Yeah, so what I'm doing is so how I'm utilizing these extra 2 queries is I'm trying 1, 2 and 3. Okay, so I'll get some value x, and then I'm trying 1 and minus 1 and n, and I'll get some value y. If x is smaller than y, then I will choose 1 and 2. No, then I will choose 2 and 3 to be my initial value pairs that I'll keep fixed. Otherwise, I'll take n minus 1 and n. And why is that so? The reason is that if 2 and 3 were, one of them was 0 and one of them was max, right? If that was the case, then this value x will definitely be greater than this. And that is why if that happens, so y is less than x, then I choose these two as my starting positions, and with the criteria that these two do not contain both 0 and a max, I am good with my solution and it will work. Notice that even if there are duplicates, the solution still works. You can work that out. I wanted to explain the more general approach. And now let's look at the implementation. So the same thing, I'm checking 1, 2, 3 and 1 and minus 1 and n, and based on whichever is less, I'm picking that to be AB, and then I go from 1 to n. If I is equals to AB, continue, because then I will ask for duplicate index. I make the query, store it in result vector, and basically keeping a track of where maximum I is, because I will need it to figure out where the possible 0 or a max is. And then forget what this count is, it's irrelevant. So answer, we have to give two possible places where it can be. So one of them is obviously mxi, and then I am updating b to be mxi, and a remains the same. Okay, now that a is remaining the same, so it was like this, right? A1, A2. Using these, I queried everywhere. I found 0 or a max. Then I used this and this to query everywhere. And again, I do the query, but this time I also keep a count of the occurrence of maximum and the total count, which is just n by n minus 2. I don't know why I stored it in a different variable. And if this time count is equals to count, that is, I get a max n minus 2 times, that means that these two that I'm selecting right now every time are the two possible answers. So I push back A because mxi was already pushed back, which was B. And otherwise, whichever is the maximum one, I will push back that. This I explained previously in the video, obviously. And then I print the answer. So that was the solution. It was a pretty good question, I think. It's just the case where the initial two values we are selecting contain both 0 and a max, kind of ruined my contest. Otherwise, I would have had at least negative 30 or something, but now negative 100. Back to expert. Yay. So that was the solutions. Hope you liked. If you did, leave a like. If you didn't, leave a like and subscribe. And I'll see you next time. Bye.